Compound interest. The compound interest formula that we'll be using for the next few problems is A equals P times 1 plus R to the T power. This is a little bit different than the compound interest formula we used in prior videos for computing future value. That's because those problems had compounding periods. The next few problems only deal with years, and we're only compounding them one time a year. So A is the future value, P is the principal or the amount deposited, R is the interest rate written as a decimal, and T is the time in years. Use the compound interest formula A equals P times 1 plus R to the T power and the given information to solve for R. A equals $2,100, P equals $1,600, and T equals 6. I'm going to take these values and plug them into the formula. So I have 2,100 equals 1,600 times 1 plus R to the 6th power. I'm working on getting the R by itself. Right now I have a 1,600 being multiplied to that expression. So in order to get rid of that 1,600, I'm going to divide both sides by that value. That will cancel the values on the right side. And now on the left, I have 2,100 divided by 1,600. When you do that calculation, you should get 1.3125. Now that equals 1 plus R to the 6th power. So this exponent of 6 is being applied to the 1 plus R expression. In order to get the R by itself, I need to get rid of that exponent of 6. So I'm going to apply the power rule for exponents. Real quick, the power rule says that if I have a number being raised to another number, then I can raise this entire expression by the reciprocal, and the exponents will cancel out. Remember, the reciprocal is just that number flipped. So for instance, if I had an exponent of 2/3, then the reciprocal would be 3/2. If I have the exponent of 6, then the reciprocal will be 1/6. Because there's really an imaginary 1 underneath all whole numbers. So I'm going to apply this rule by raising both sides to the 1/6 power. Because remember, whatever you do to one side, you have to do to the other side of the equation. All right, so now I have 1.3125 raised to the 1/6 power. And on the other side, I have 1 plus R raised to the 6th power raised to the 1/6 power. So remember, if I have a power raised to a power, I multiply those things together, and 6 times 1/6 is just 1. So on the right side, this leaves me with just the expression in the parentheses, which is 1 plus R. Now I have to do the calculation of 1.3125 raised to the 1/6 power. To do that, go on your calculator, type in 1.3125, find the exponent key, which is probably the upward facing arrow key, or X to the Y key, or Y to the X key. Then you're going to type in parentheses. There should be an open parentheses on your calculator. It's a button. Then type in 1 divided by 6 then type in the closed parenthesis button, and then push equals. So when you do 1.3125 raised to the 1/6 power, you will get 1.0463650343, and it equals 1 plus r. Now I want to get the r by itself, so 1 is being added to r, so I do the opposite operation and subtract 1 from both sides. You're left with an r on the right side, and this decimal minus 1 is 0.0463650343. So that is what r equals as a decimal. But we want to write this as a percent. So in order to write this as a percent, all you're going to do is multiply that decimal by 100 or move the decimal point 2 places to the right. And this will give me a value of 4.63650343%. And my math lab is going to ask us to round to 2 decimal places. So I look at the number in the 3rd decimal place. This is a 5 or greater. So that means I'm going to round the number next to it up. So my rounded percentage is 4.64%. And that is the final answer. We'll type in 4.64%. Notice that the percent symbol is already in our answer, so we only need to type in 4.64. Use the compound interest formula, A equals P times 1 plus R to the T power, and the given information to solve for T. A equals 39,000, P equals 26,000, and R equals 7%. So I'll plug these values into the formula. When I plug in the value for R, remember that has to be a decimal value. So 7% written as a decimal is 7 divided by 100, which is 0.07. And that's raised to the T power. So T is the value that I want to solve for. The first step is to get the expression attached to the T by itself. So I'm trying to get this expression by itself. Right now, 26,000 is being multiplied to it. So I need to do the opposite operation and divide both sides by 26,000. On the right side, I have 1 plus 0.07 raised to the T power. And on the left side, I have 39,000 divided by 26,000, which is 1.5. Now I'm going to solve the calculation in parentheses. So this is 1 plus 0.07. So I can go ahead and add those two values together, and I get 1.07 to the T power equals 1.5. Okay, now notice that I have the variable in the exponent position. Remember, when I have a letter or a variable in the exponent position, I need to take the log of both sides so I can then move the exponent out of the exponent position. So now I'm just going to take the log of both sides. So I have the log of 1.5 equals the log of 1.07 to the t power. Now I'm going to apply the power rule for logarithms and take that exponent and move it in front of the log. Now I have log of 1.5 equals t times log of 1.07. T is being multiplied by the log of 1.07. So to get the t by itself, I'll just divide both sides by the log of 1.07. Now you need to use your calculator to do log of 1.5 divided by log of 1.07. When you do that calculation, you should get t equals 5.992805,314. My math lab asks us to round to the nearest integer or whole number because t represents the number of years. So I'm going to round this number to the nearest whole number. So 5.992805,314. If I round it to the nearest number or whole number, I look at the value to the right of the decimal. That's a 9, so that tells me that I'm going to round that number up. So t is 6. So my answer is 6 years. We'll type E6 into the answer box.